Hello everyone, my name is Shabani Ashimu Mchomvu, and today we are going to learn a topic of differential equation, which is a part of calculus, and we are going to see the introduction in it. Differential equation is an equation containing the derivatives of one or more dependent variable with respect to one or more independent variable. That say, maybe if you have, this is just a derivative, dy dx plus maybe y equals to maybe 2x. So that's the differential equation where we can see the independent variable x and dependent variable y. Differential equation, we can classify them by type. Specifically, we have two types: ordinary differential equation and the partial differential equations. Now let's see their difference. For the case of ordinary differential equation, if a differential equation contains only ordinary derivatives of one or more dependent variables with respect to a single independent variable, it is said to be an ordinary differential equation. So here what we try to check, the single independent variable that's really present on the equation. Here we have the second derivative, that's dy dx, the second derivative, plus dy dx, the first derivative, plus y equals to 0. So you can observe here the independent variable x, so has not changed. We have x and here we have x. So this belongs to ordinary differential equation. Now for the second part, that is partial differential equation. If a differential equation contains partial ordinary derivatives of one or more dependent variables, so dependent variable can be one or more, with respect to two or more independent variables, it means we have a number of independent variable, can be one or more than that. So it is said to be a partial differential equation. As you can see here, we have the partial differential equation that involving the dependent variable u and independent y, and this one is independent variable v, and this one is independent variable x. So that's belong to partial differential equation. The same apply here. We have dependent variable x and y, but also here we have the independent variable y and the x. So this form now the classification of differential equation by type. So let's see also the other terms that are involved in differential equation, order and the degree of a differential equation. Starting with the order of a differential equation, the order of a differential equation, either of ordinary differential equation of this type or the partial differential equation, is the highest derivative in the equation. So what we check here, from our differential equation, we are checking the highest derivative reached in that equation. For example, let's say third derivative of y with respect to x, we plus 2 the square root of y dx square now equals to 0. So that is ordinary differential equation. So the order here, we are trying to check the highest derivative reached. The highest derivative reached, it is third derivative. So from here we say this is differential equation of order 3. That of order 3. But also we can just see this also example, that is x dy dx equals to y minus 1. So when you observe this differential equation here, we have the first derivative. So it means now the order becomes 1 because we have differentiated, it was differentiated for the first time. So the highest order derivative reached, it is 1. So we say this is order 1. And what if this was not there? It means this one now becomes of order 2, because the highest derivative reaches the second derivative. Having said that, let's also see the degree of a differential equation. The degree of a differential equation is just the power of the highest order derivative in the differential equation after the radicals or the square roots have been eliminated in that differential equation. Let's say here we have this one. Maybe plus 2 second derivative equals to 0. So as you can see from here. So here we are trying to, the first thing that we are going to note here, the highest order derivative. So our highest order derivative here, it is the third derivative here. This is second derivative, so the highest is this one. After there now, you try to check the power in it. So the power here is 1, because when we try to write like this, it means we have the power of 1. So this now becomes a differential equation of degree 1. Degree 1, though the highest derivative reaches the third derivatives. So from there now, we're going to see how we formulate these differential equations from the normal equation that involving dependent variable y and the independent variable x. Okay, so the formation of a differential equation now, we can say, how do we generate, how do we formulate these differential equations? So what we are trying to see here is how now we eliminate those constants that will just exist in the functions. So we say on formulating the differential equations, we eliminate the arbitrary constant from the functions. Now, these arbitrary constants are decisional constants that we need to eliminate them so as we can have a differential equation that will involve the independent variable and the dependent variables. For example, examples, maybe we are supposed to formulate differential equations from the functions below. Number 1, y equals to a, the sine of x, with plus b, the cosine of x. So we have a function here that involving the variable x and y, and here you can see the constant a and the constant b. So for we to formulate differential equation here, we need to eliminate constant a and the b. So whereby that a and the b are constants. So we need to eliminate them. So on how to eliminate them, it means now we are relying on the concept of differentiation, because differential equation involves differentiation and the integration. But for we to eliminate, it means differentiation here works the best. So solution from y equals to a sine of x with plus b the cosine of x. So we can differentiate for the first time with respect to x. So here dy dx equals to, so here we differentiate normally because we don't involve independent variable which is not x. So we just differentiate normally. So here we keep constant a, this one. When we differentiate signs, we get the cosine of x. And the plus, when we keep constant sine of x and differentiating now, this a here becomes 0 because a does not concern with the x, the variable of respect. So here is just 0. Now we plus, the same apply, we keep constant b, differentiating cos, we get negative sine of x. Now we plus the cosine of x, and now when we differentiate constant b, here we have 0. So what we have, we'll have a cosine of x, then minus b, the sine of x. Still, the arbitrary constant a and b exist. So we can just go for further derivatives. So we can differentiate for the second time because this is the first differentiation, y prime. So if we go for the second time, with respect to x, now becomes, it means you differentiate the first derivative expressions. Here, when differentiate cos, we get negative sine. So it becomes negative a sine of x. And coming here, when differentiating sine now, we get cos. So it becomes minus b, the cosine of x. So from here, now you can try to check how now this a and b as constants can be eliminated. So we can try to find a way to relate the second differentiation, the expression for the second differentiation with the first function. So if we take out negative here, so we'll have negative, then a sine of x, now we plus b the cosine of x. So this a sine of x plus b cosine of x, now it's related with what? With y from the functions. So what we do, it's a matter of now, because we don't want to see a and b, we are going now to substitute this y where a sine x plus b the cosine of x. So here you'll have the second derivative now equals to negative. This now becomes y. So up to this point now, you have removed the arbitrary constant a and b, and what you have now is a differential equation, which is ordinary. That is example number 1. Now let's switch to example number 2 of different functions. Y equals to a, e raised to 2x, now plus b, e raised to negative 3x. So that is a function involving, we can say is exponential function. It involves Euler's, that is e, exponential functions. So from this function here, a and b are constants. And have to be eliminated. Solution. From y equals to a raised to e 2x plus b e minus 3x. We don't have a known approach that we can use, but also you can try to check how to simplify and eliminate a and b. So by starting, it is better now to remain with one arbitrary constant, either a or b. How? It means we need to remove this exponential function, this e raised to negative 3x or e raised to 2x, so as we can have free constant a or b. So once applying now the differentiation, it can be eliminated. So maybe we can choose maybe here we want to divide by e raised to negative 3x both sides to see what we have. So on dividing by e raised to negative 3x throughout, we have, so it becomes y over e raised to negative 3x equals to a e of 2x. Here we have e raised to negative 3x. Now we plus b over e raised to negative 3x. So from here, this one and this one goes, and here it becomes y So you can reciprocate this one. You can express in reciprocal, and it becomes e then positive 3x equals 2. When dividing the same base, we subtract exponent. So the quotient law of exponents works. So it becomes a e 2x minus negative 3x. Here it means we get 5x. Now we plus here b, because this one and this one cancel out. So from there, now arbitrary constant b is free. So we can apply now differentiation, first differentiation. So this one can be cancelled out. So here to the left hand side, because we have two variables, y and x, it means we differentiate implicitly. But here to the right hand side, we differentiate normally, because we have only one variable x, which is the letter of respect. So the product rule now works here in differentiation techniques. So keeping constant y, differentiating e raised to 3x, it means we are going to get 3 e raised to 3x, plus keeping constant e raised to 3x. Now differentiating y, we get 1, but we just leave this differential coefficient, dy dx. So this is less more 2 here. Now differentiate normally, we get 5a e raised to 5x, then plus c, 0. Now b becomes 0. So from there, we have 3y e raised to 3x. Now we plus e 3x dy dx equals to 5a e raised to 5x. So now one arbitrary constant b has been eliminated. So we have remained with constant a. So again, we are going to perform the same thing, that we divide by e raised to 5x, so as we can let this term, or we can set the term to remain with only the constant. From here now, we can divide by e raised to 5x throughout and see what we have. So we'll have 3 y e raised to 3x. Now dividing by e raised to 5x. We plus e raised to 3x over e raised to 5x. Then dy dx equals to 5a. So it means here 5x. Now when we divide by e raised to 5x, as at these terms here to the left hand side, so this goes. And what remains here, it remains 5a. So now here we have the possibility now of eliminating a. By how? We can perform the second differentiation. So we simplify first, it becomes e. Now 3x minus 5x, because we are dividing the same base, so we subtract exponent, becomes minus 2x. Now we plus e negative 2x, then dy dx equals to 5a. So now we apply second differentiation. So keeping constant 3y, now differentiating this becomes negative 6y e raised to negative 2x. Now we plus, keeping constant e raised to negative 2x, differentiate y, we get 3 e raised to negative 2x, then dy dx. Now we plus, keeping constant e raised to negative 2x. Differentiate dy dx, we get the square root of y dx squared plus. Now we keep constant this dy dx, we differentiate this. Here it becomes minus now. It becomes minus 2e raised to negative 2x, then dy dx equals to, derivative of 5a becomes 0 because that is constant. So from there, now we can collect the like terms, the terms with the same differential coefficient. For example, here, the second differentiation coefficient here has no, its pair. So it becomes e negative 2x, the square root of y dx square. But this with the dy dx, it is found here and here. So we can collect these terms. So 3e raised to negative 2x, and this one, when we operate here, it becomes positive, e raised to 2x minus, then dy dx. It means we have operated their coefficients, 3e raised to negative 2x minus 2e raised to negative 2x. It means you get e raised to negative 2x, then dy dx. Then from there we minus this one, 6y, e raised to negative 2x equals now to 0. So from here we can divide by e raised to negative 2x. And what we have now, so we'll have d squared of y dx square. Now we plus dy dx, we minus 6y equals to 0. Or it can be expressed as y double prime plus y with y prime, then minus 6y equals to 0. So we have already now formulated the differential equation whereby the arbitrary constants a and b have been eliminated. Thank you.